Hello, myself Zubair from group 3 to 4. Today, my topic is topic number 3.4.1, that is physics of sound. A sound wave is a mechanical wave that moves through a medium as the particles in the medium are displaced relatively to each other. It should therefore anticipate that the mathematical description of sound have similarities with the description of other mechanical dynamic systems. The simplest possible dynamic system is the harmonic oscillatory, consisting of a point mass attached to earth by an ideal mass spring. If the mass is displaced to the equilibrium position of amount x, then a force will be developed in the spring that tries to restore the system to the equilibrium condition. The restoring force F acting on the mass is proportional to extension of spring and acts as positive x direction with the spring is compressed, that is F is equivalent to minus of kx. Newton's second law applied to the mass yield the equation minus kx is equivalent to F is equivalent to ma is equivalent to mx, where denotes a differentiation with respect to time. Rearranging the equation and introducing a constant for the system, that's mu is equivalent to under root of k by m, where x is equivalent to mu square, x is equivalent to 0. The solution of the equation is sinusoidal in form. The general solution of the equation is x is equivalent to d cos of omega t plus e sin of omega t. The two constants d and e were determined by an initial condition, that is by how much the mass is displaced from the equilibrium condition at the time at the measurement commence, and by the velocity that is imparted to the mass at that time. There are several alternative ways in which this solution can be expressed, and very often in medical physics and biochemical engineering, other forms of the solutions are most valuable in this. We investigate alternative ways of writing the same solution. One method we find particular useful in express in terms of a single sinusoid. In this expression, the cosine and sine amplitudes constant d and e are replaced by composite amplitude c and a phase shift phi. X is equivalent to c sine of mu t plus phi. We might also express the equation and its solutions in terms of complex exponentials, and this form of expression will also have its place for the description of sound waves. We conventionally use the phase from described above. Simple harmonic motion is often initiated by displacing the mass of a given position and then letting go. Under these conditions, the initial velocity is 0. Substituting these initial conditions into the governing equation, we found that the phase shift is 90 degree and x is equivalent to c cos omega t. In a sound wave, the particle in the medium acts much like the mass in the simple harmonic oscillator. It is convenient to consider the motion of small element of the medium. The principle of the motion sound wave can be demonstrated earlierly in one dimension of consideration of a tube of air excited by an oscillation piston at the end. The wave equation for longitudinal mechanical wave is derived. The wave equation for longitudinal mechanical wave is derived in a number of texts. We follow a similar derivative that the given by Keller et al. In 1993. We can consider the position of a particle, or in this case of element of fluid as it travels through the time and space, assuming the displacement in the axial direction of the element of a fluid initially at a position x. At any particular point of time, the element that was initially situated between x and x plus delta x moved as illustrated. Assuming the cross-sectional area of the tube is constant and equal to a element of a fluid exchanges in volume as follows. Initial volume is equivalent to v naught is equivalent to a delta x. Volume at time t is equivalent to v is equivalent to a delta x plus phi x plus delta x plus t minus phi into t. Hence the change of the volume in the element of the fluid is delta v is equivalent to a phi x plus delta x t minus phi x t, and the fractional change in the volume is delta v by v, that is equivalent to a phi x plus delta x t minus phi x t divided by a delta x in the limit when we give the limit as delta x tends to 0 in terms of right approach. That is it. That is all from my side. Thank you. Have a nice day.